Hello everyone. So in the previous video we talked about how to follow different steps to determine the empirical formula. Here we're going to cover a practice question. So a compound of iron and oxygen is analyzed and it is found to have 69.94% iron and 30.06% oxygen. Now how do we determine the empirical formula of this compound? First of all, what you should always do when having practice questions that contain data, numerical data, is to note it down in a certain piece of paper. So we have the given data. We have the percentages of iron and oxygen, respectively 69.94% for iron and 30.06% for oxygen. Now, how do we determine the empirical formula? First of all, we know that when we have different compounds, we first write the cation and then the anion. So here we're going to write the metal first and then the non-metal. But we do not know the subscripts or the numbers that we're going to use as subscripts, which show the ratio between the iron moles and the oxygen moles. So we just write them as question marks. Now let's follow the first step, saying that we have to assume a 100-gram sample and convert the same percentage values as grams. So if we had 69.94% iron and 30.06% oxygen, then in 100 grams of this sample we have 69.94 grams of iron and 30.06 grams of oxygen. The second step tells us that we have to convert these grams into moles, and we do that by dividing these grams with the molar mass of each element. So we do this by writing 69.94 grams of iron and dividing this by the molar mass of iron, which is 55.85 grams per mole. And the result is around 1.252 moles of iron. We do the same with oxygen, but here we have to see that we're not dividing this by 32, we are dividing it by 16 grams per mole, which is the molar mass for oxygen and not molecular oxygen. And we get an estimate of 1.879 moles of oxygen. Now let's follow the third step, saying that we have to divide these moles by the smallest of the results. And the smallest is the number of moles of iron, which is 1.252. And we divide both of them with this value. And we get it to be around 1 for iron and 1.5 for oxygen. But we cannot use 1.5 as a subscript. We have to use whole numbers. So what we do is that we follow step 4. So we multiply each of the moles by the smallest whole number, and then we can convert this into a whole number. So if we have 1 and 1.5, then to make 1.5 a whole number, we just have to multiply it by 2. And 1 times 2 is 2 for the subscript of iron, and 1.5 times 2 equals 3 as a subscript for oxygen. So we're going to have the result being Fe2O3. So this is going to be our empirical formula. And we know that the subscripts should be whole numbers for sure. That's why we followed step 4 and we did not skip it. And we're going to have this compound being named as iron 3 oxide. So because we have iron forming different cations, just like we said in the video about naming compounds, then we have to write the valence of the metal, which is the same as the charge of its cation in parentheses written as a Romanian numeral. That was all for today. Thank you for your attention.